Hi guys. So like I said earlier in the other video, the second half of the week, we will be looking at all of the stuff we've done with quadratics so far. So, um, starting with vertex form, that's what we started with first. It's kind of dealing with transformations and stuff, up, down, left, right, stretch, compress, reflect, blah, blah, all that stuff. So, but the best part of vertex form is that you can just pull the vertex straight out. How wonderful. So just remember that you have to flip the sign of whatever's in parentheses with x. So A says state the vertex. Well, my vertex is the point -2, -1. There we go. Took a second. It says describe the shape of the quadratic. Well, we know that it opens up because A is positive, and A is 1/2, which is in between 0 and 1. So it is wide or compressed. Either word works. You don't have to write both. And then sketch a graph of the quadratic. So at -2, -1, it's going to be a wide parabola. Like that. Like a very wide U. Okay, and then it says state the domain and range. So domain, as hopefully everybody knows by now, for every quadratic ever, unless you are restricting it for some reason, it's always going to be all real numbers. Why, you may ask? Because it goes forever in both directions. So x can be any number ever. There's no such thing as a number you're not allowed to plug into a quadratic because of some weird math rule. Okay? You can square anything. You can imaginary numbers. Whatever. Why am I saying? I'm just saying things. Okay. As far as range, range deals with the y's. Now, all of the points in my parabola are above the vertex. So I'm going to say that my y's are all greater than or equal to -1. Ta-da, there you go. Vertex form. Woo! Okay, the other thing that we have worked on is standard form. So in this case, we're going to look at the vertex and the y-intercept. So the y-intercept is like super easy, right? So it's just C. So the y-intercept is the point 0, -9. I can go ahead and plot that point too because it's right there. Sometimes we don't always see the y-intercept on the graph, but we do this time. Sorry, there's a flying bug in my house. All right, for the vertex, that's where we use that formula, x equals -b over 2a. So here's a and b. Now, that just gives us the axis of symmetry, which tells us the x of the vertex, because the axis of symmetry, if you remember, runs straight through the vertex, which now that I'm thinking about it, I should have put the axis of symmetry on this review, but hopefully you guys watched the video and hear me talking about it right now. But anyway, so in this case, it's going to be -8 over 2 times -2. Negative cancel each other out, so it becomes 8 over -4, which is just -2. Now to find the y of the vertex, I just take the x and plug it into the equation, see what I get. So in this case, I'll get -2 times -2 squared minus 8 times -2 minus 9, which gives me 2 times 4 is -8, plus 16 is 8, minus 9 is -1. So my vertex is the point -2 and -1. One of the things we did do was we took that and wrote it into vertex form. When I was grading, I feel like most people were pretty good at that. So did not put that on here. Didn't think to. Gosh, hindsight's 2020, you know? Anyway. So sketch a graph of the quadratic, -2, -1. And, oh, I forgot to describe the shape. I was going to go ahead and graph it without describing the shape. I'm getting a little cluttered, so I'm going to do it up here in blue. It's negative, so that's going to open down or be reflected, however you like to say it. Also, it is a 2, so we know that it is more narrow or stretched. There we go. Give me some more space. Right. Okay. So, that there. Oh, there is my lovely quadratic. Please remember to put arrows on it because they do continue forever and ever and ever. As far as domain and range, once again, domain is always all real numbers with quadratics because it goes forever in both directions, left and right. The x-axis is left and right. It may look like it's going left or right kind of slowly because it's so narrow, but it will in fact continue forever, often to infinity, to the left and to the right. As far as range, that's dealing with the y-axis, which is up and down. Now, all the points on this quadratic are below the vertex, or like including the vertex. So I'm going to say that all of the y's are less than or equal to -1. So hopefully we're doing good with domain and range. Hopefully we're doing good with standard form, vertex, graphing, all that stuff. Look at all the stuff you guys know about quadratics. You guys are awesome. Okay. X-intercepts and describing the shape. So this one is already factored for us. So all we have to do is set each factor equal to 0 to find out what the x-intercepts are. So in this case, 7x minus 3 equals 0. Some people can do that in their head. If you are one of those people, that is fine. You don't have to show me your work. If you look at that and you're like, people do that in their head, that's crazy. Yeah, no big deal. It's just a 2-step equation, right? So we're getting rid of the 3 first by adding 3 to both sides. Those cancel out, bring down the 7x. 0 plus 3 happens to be 3. Then I divide everything by 7, and I get 3/7. This is 3/7. Please keep things in fractions when possible because fractions are more precise than decimals. Okay. In general, I mean, 0.5 or 1/2, like whatever. But fractions are better. I like them better. So that's my class. So this one, x plus 7 equals 0. So essentially you just have to flip the sign of 7 to -7. So that means that my x-intercepts are the points, because remember, x-intercepts are points, not numbers. 3/7, 0, and -7, 0. The shape of my quadratic is based on A. It's negative, so it opens down. And it's 6. Oh, right. You could also say reflected. I'm sorry. Reflected is the more proper word anyway. I'm not even saying it. Reflected. And it's 6, which is more narrow or stretched. Cool. Okay. So next, for the other two that I have examples of, we have to actually factor them. Okay. So with factoring, first thing we want to do is if we have a greatest common factor, we want to do that first. So we're looking to see if x squared and 64 have anything in common that we can divide out, which no, they don't at all. So we're just going to go straight to factoring. So I'm looking for two things Well, okay. First, let's remember that the b term is missing. So if we wrote this with the b term in, it would be x squared plus 0x minus 64, right? Because b is missing because we don't normally write 0 in. But essentially what we want is we want something that multiplies to negative 64 and adds to 0. So I recommend, unless you like it good at these in your head, which is totally awesome, if it helps, I recommend writing a list to the side, right, of just all the things that multiply to 64. So start with 1 and work your way. Oh, for crying out loud. So you got 1 and 64. Because it always got 1 in the number. 2 and 32. 3 would give you a decimal. 4 and 16. 5's a decimal. 6 is a decimal. 7's a decimal. Then you got 8 and 8. And at that point, you can stop because then you'd start repeating yourself. So the only one of those that I could put together to get 0 would be 8 and 8. In fact, this is a special kind of quadratic factoring thing that's called difference of squares. If you have a perfect square minus a perfect square, you're essentially doing a formula where it's the square root of the first one minus the square root of the second one and the square root of the first one plus the square root of the second one. Because I have to have the exact same numbers, just of different signs to add up to 0. Okay. So that is factored form. Hey, cool. So in this case, when x minus 8 equals 0, I get x equals 8. When x plus 8 equals 0, I get x equals negative 8. So in this case, my x-intercepts are the points 8, 0, and negative 8, 0. Nacho, quit picking on the dogs. They're so mean. Anyway, as far as the shape of this quadratic, a is just 1, so it's pretty standard. It opens up and is the standard size. Hey, Nacho. This is my cat, Nacho. He's mean to my dogs. He's mean to the other cat, too, sometimes. It's always nice to me, though. So one more. With this one. First thing I'm going to do is look for a greatest common factor, something that I can divide all 3 of those numbers by. And lo and behold, I can divide them all by 6. Isn't that cool? So I'm going to. It's called factoring out a 6. So I'm going to put the 6 in front because it doesn't disappear from the equation. We're just moving it out, right? So 6x squared divided by 6 is just going to be x squared. 18x divided by 6 is just going to be 3x. And negative 240 divided by 6 is going to be negative 40. So now I want to factor. I am looking for 2 numbers that multiply to negative 40 and add to 3. So I'm going to list off the things that multiply to 40. So I've got 1 and 40, 2 and 20. 3 would give me a decimal, but I've got 4 and 10. And then 5 and 8. 6 and 7 would give me decimals, and then I'm back at 8, and I'd be repeating myself. So we want to get 3. Because 40 is negative, we're going to have to subtract because they have to be different signs to multiply to get a negative. So I'm going to use 5 and 8. Doesn't matter which order you put them in. Multiplication is commutative. Biscuit, that's rude. We're making a video. So, question is, which one's positive and which one's negative? Well, I want to get positive 3. So that means that I want the bigger number to be positive and the smaller one to be negative, so that when I add them together, I get positive 3. So as far as my x-intercepts, x minus 5 equals 0, and x plus 8 equals 0, which just gives me 5 and negative 8. So remember, my intercepts are points. They're the point 5, 0, and negative 8, 0. Last thing is to describe the shape. The number we factored out is positive. 6 is my A, so it is positive. So it opens up. And it's 6, which is bigger than 1. So it is narrow. 6 would be really narrow too. Or stretched. So anyway, that is just kind of the main big ideas from quadratics that we've covered so far. I mean, there's more about quadratics, but it's big ideas and the stuff we've covered so far. I will see you guys at the live meet.